Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 1.3.3, which is angles formed by more transversals, which is kind of odd. I think it should be called more angles formed by transversals, but who am I to argue with the book here? But here we go. I figured I would start off with one of the last examples in the last section where we were given an angle. Angle B was measured at 60 degrees, and we had to determine the angle measures of all the other ones. We determined from that work that through vertical angles that angle C would be 60 degrees also, and that angle X is also 60 degrees, and that's because angle B and angle X are corresponding angles, and that was a term that we used in the last section, corresponding angles. Remember, it is simply a reference to two angles that are in the same corresponding position. They're in the same position, but they have different locations. And so angles B and X are corresponding, which means they're congruent, right? Because the lines are parallel. By that, we could also say that angle Y was congruent to angle X. Again, there goes that vertical angle idea. From here, the red angles, the A, the D, the W, and the Z, we determined those to be 120 from a couple of different ways. Either a linear pair. Remember, linear pairs are supplementary, meaning they add up to 180 degrees. Angles A and B are supplementary. They are a linear pair, and if one angle is 60, the other one's got to be 120. And then again, you could just do the 120 here, and I should just start marking this up, that way you guys know what I'm talking about here. The 120 here and the 120 here, vertical angles. 120 here and 120 here, again, vertical angles. So hopefully those angle relationships make enough sense, but let's go ahead and get them down in writing before we move on. Let's go ahead and call the angles what we are. Corresponding angles. Angles B and X are corresponding. Angles A and W are corresponding. Angles C and Y are corresponding. And angles D and Z are corresponding. And again, those corresponding angles are corresponding because they are in the same position but in a different location. The next set of angles we talked about, again, those vertical angles. Let's go and list those out. Vertical angles here. Those vertical angles were A and D, B and C, then X and Y, and then W and Z. Those were vertical angles. And again, we know that vertical angles are congruent, and because these lines are parallel, the corresponding angles are congruent as well. Today we're going to be learning about two separate sets of angles, or three separate sets of angles, and what their relationships are in parallel lines. Now, the first one that I want you guys to pay attention to is look at the numerical relationships here. Not only is D congruent to A, but D is also congruent to W, and it's also congruent to Z. Well, what is the relationship that makes that so? Well, again, D and Z, we covered that up here. They're corresponding, so it makes sense that they would be congruent. But what is the relationship called that relates the D angle to the W angle? Well, that is what we call an alternate interior relationship. And hopefully those words, when put in that sequence, make enough sense. Alternating, meaning they're on opposite sides of the transversal, and then interior, meaning they're on the insides of the parallel lines. So let's go and write those down. Alternate interior angles. And again, I'll just go and list them off for you. D and W are alternate interiors, and if you look really hard, you might be able to tell which one's the other one. I'll even give you a couple seconds if you want to pause. If you were saying C and X, you would be correct. Those alternate interior angles, those are absolutely congruent to each other. Again, alternate interior, the alternate meaning opposite sides of the transversal. Opposite sides of the transversal. Interior meaning inside the parallel lines. And that's what it means to be alternate interior. Now, with that in mind as well, it wouldn't be so hard to assume that alternate exterior angles also exist. Again, alternate meaning opposite sides of the transversal, and exterior meaning outside of the parallel lines. So I'm sure you can guess what they are. It's B and Y, as well as A and Z, right? Again, alternate opposite sides of the transversal, exterior meaning outside the parallel lines. Okay, so now from here, we can also say that, that there's another set of angles going on here, and if we look at them, look at D and X. Look at D and X, right? And look at the relationship they have with each other. One of them is 120 degrees, the other one is 60 degrees, and it's very similar to your linear pair relationship. Now, remember, linear pairs are supplementary, and that is because supplementary angles by definition sum to 180 degrees. Well, these two angles, D and X, and quite frankly, as well as C and W, both are supplementary angles. And what we call those is unlike instead of alternate interior angles, we call them same side interior angles. Same side interior angles. Again, not because they're not alternating, right? They're on the same side of the transversal, and they're on the inside of the parallel lines. So from here, we can say D and X are same side interior angles, as well as C and W are also same side interior angles, and unimaginably, same side exterior angles also exist, in which case you'd be looking at A and Y, as well as B and Z. I'm going to move these guys down a little bit further because they qualify under a separate category of parallel relationships. All of these guys here, these all have a congruent relationship. They're all congruent to their respective parts. These guys here, these guys are supplementary, meaning they sum to 180 degrees. So as long as you can keep those kind of in your back pocket, then the assignment should be pretty easy. Let me pause real quick and I will get to it. And here we are with 1-93. So it says, suppose angle A in the diagram at the right measures 48 degrees. So that's going to be this angle right here being 48 degrees. Now again, notice that the arrows are happening on the lines, meaning that the lines are parallel. And it says, use the angle pair relationships to solve for angle B. Well, from here, you can go ahead and actually say that you could use this to say that this is angle A, and then use the corresponding relationship, or you could go back to the notes from right above and notice that A and B are alternate interior angles, in which case this guy's got to be 48 degrees as well. So that should be pretty straightforward as long as you know the relationship. When it comes to Julia having trouble seeing the angle pair relationships, and we have Alethea explaining translating an angle, this one you're supposed to use patty paper for and really trace and see if the angle relationship is supplementary or congruency. But we know these relationships from the notes above, and so we can say that angles A and B are same side interior, and therefore they are supplementary. Angles A and B are going to be, looks like congruent, right, because they're same side exterior, so alternate exterior. Alternate exterior, and that's going to be congruence. Now A and B here, these guys don't really have a relationship that has a term attached to it, but they are going to be supplementary because of the supplementary relationship of the same side interior translated into the vertical. So I would just call this thing supplementary right here. And there's 1-93. I'll be back with 1-94 and 95, and we will be good. And basically the way this section wraps itself up is it gives you a bunch of definitions for alternate interior angles and same side interior angles. And basically what you need to get out of this is exactly what we discovered in the beginning of the lesson, and that is that if where'd that thing go? Oh, here it is. Okay. Sometimes the white on white background makes it hard to see. If the lines are parallel, then the alternate interior angles will be congruent. And then same thing down here. We can say if the lines are parallel, then the same side interior angles will be supplementary. And that's going to cross over the screen here. Here we go. And I believe they also give you this. They give you this right here. I'll go and highlight it in blue here. Something like this. If lines crossed by a transversal or parallel, then the blah, 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 blah. And then same thing that goes with this guy here. So here we are. We could do the proof of it right now real quick. It wouldn't be that hard if we're going to do Claudio's proof here. He's starting off with the fact that A plus B is equal to 180. He knows this because A and B are a linear pair. He knows that A is equal to C, and that's because they are corresponding angles on parallel lines, which means he can go ahead and just make the substitution, right? If A equals C, he can then say C plus B is equal to 180, and therefore the same side interior angles are supplementary. So that will just about wrap it up for this section of the lesson. As always, feel free to leave comments, or rather questions, in the comments area, and I will see you in the next lesson.